Hello everyone and welcome. In this video we will be introducing the ARCO 400, a universal test set designed to simplify and speed up Recloser control testing. The ARCO 400 brings a smart plug-and-play approach, allowing you to perform a complete testing in less than 15 minutes, even in a challenging field conditions. It's lightweight, rugged solution that supports multiple control types and manufacturers, making it a truly flexible tool for modern power systems. Throughout this presentation, we will walk through its features, capabilities, and how it improves testing efficiency and reliability. Let's get started. Before we go deeper into testing, let's quickly understand what a recloser consists of. A recloser is not just a switching device, it actually includes all the key elements of protection system, similar to what we see in a substation, but all combined into one compact unit. First, we have the circuit breaker, which can be a single phase or three phase, and this is what interrupts the fault current. Then we have the recloser control. This is the brain of the system. It takes all the input signals and makes decisions based on the protection logic. We also have sensors like current transformer or Goski coil, and sometimes voltage sensors. This provides the measurement inputs needed for protection functions. Next is the power supply. Normally the unit is powered from the grid, but it also includes a battery backup. This is important to keep the controller active even if there is a loss of supply, so it can continue to operate and respond to faults. In many cases, communication is also included, allowing the recloser to be connected to SCADA systems for monitoring, control, and data collection. All these components are connected through control cables that carry measurement, status signals, and control commands. So even if the recloser is installed out in the field, it performs the same role as a fault protection system, and that's exactly why proper and complete testing is essential. Now, let's look at a typical recloser setup focusing on the signal exchange between the controller and the circuit breaker and why this is important for testing. At the core of this setup is the control cable. This is the main link between the recloser on the bowl and the controller. During testing, we completely isolate the controller from the real system. We disconnect this control cable and connect the test set instead, so the controller only sees a simulated signals. That's why it's very important to understand what signals are actually passing through this interface. First, we have the measurement signals. The controller receives a three-phase current measurement and voltage measurements, which can be set up to 6 voltage depending on the setup. These signals comes from CTs and VTs and are used for protection function like overcurrent and voltage-based protection. Next, we have the status feedback signals. The controller needs to know the actual position of the breaker, so it receives open and closed status through auxiliary contacts, typically known as 52A and 52P. There can be additional signals like a manual lookout or a yellow handle status, which tells the controller if the device was manually operated. And finally, we have the control commands. The controller sends a trip and close commands to operate the recloser. So in simple terms, we have three main signal groups: measurement, status feedback, and control commands. Understanding these signals is the key for testing because we need to simulate the inputs correctly and verify that the control response as expected. Now let's look at a recloser and sectionalizer and how they work together and what's the key differences. Both devices are used to improve the reliability of the distribution system. Starting with the recloser, its main role is to reduce the outage time, especially for temporary faults. For example, if there is a transient fault like a lightning strike, the recloser can trip and then automatically close again. So if the fault is gone, the service is restored quickly. Also, a recloser can interrupt a fault current as it's a circuit breaker. Now let's look at the sectionalizer. A sectionalizer cannot interrupt the fault current by itself. Instead, it works together with the upstream recloser. It counts the number of fault interruptions and then opens during the dead time, meaning when the upstream device is open and there is no current flowing. So in simple terms, the recloser clears the fault and the sectionalizer helps to isolate the faulty section. Together, they improve system reliability and reduce the number of customers affected by outages. Now let's look at a practical example, which is the bowl-mounted recloser. In this setup, we have a vacuum switch installed on the bowl. This is the device that actually opens and closes to interrupt the fault current and restore the service. You can also see a communication antenna which allows remote monitoring and control. There is also a voltage transformer or VTs which used for both measurement and power supply. The current and voltage signals are taken from the line and reduced to a safe levels using sensors inside the unit. All of this information along with a control signal is sent through a control cable down to the Recloser controller. The controller itself can be mounted at different heights. Sometimes it's close to the ground for easy access, and in other cases it can be installed higher up near the Recloser. This type of reclosers are typically used for light and remote loads, for example in the industrial areas. The main goal is to improve system reliability by clearing fault quickly and reducing outage time, restoring service automatically when possible. The second example is the pool-mounted sectionalizer. At first look, it looks similar to a recloser, but there is a one key difference. Instead of a vacuum circuit breaker, sectionalizer uses a simple switch or disconnector. This means it cannot interrupt the fault current. So how does it work? The sectionalizer operates together with an upstream device like a recloser. When the fault happens, the recloser clears the fault current first. During the open or the dead time of the last reclose shot, the sectionalizer opens to isolate the fault section of the line. This allows the healthy parts of the network to remain energized, which improves selectivity and overall reliability. In terms of components, we mainly have the switch on top and the controller unit below. Some setup may also include the communication and VT for power supply, but overall it's a simpler system compared to a recloser. And one of the main advantages is low cost, as the sectionalizers are typically more economical since they don't include a full circuit breaker. The third example is pad-mounted recloser, which is a metal enclosed recloser and looks like the ring main units are in use. In this case, the same recloser components are used, but instead of being installed on a pool, everything is mounted at ground level on a pad. This setup is commonly used in the distribution system, especially where a full substation is not required. You will typically find the equipment enclosed within a fenced area. This is mainly for safety to prevent unauthorized access or accidental contact. Functionally, it works exactly the same as pool-mounted recloser, providing protection, fault interruption, and automatic restoration. The difference is mainly in the installation style and accessibility. So here, let us answer an important question. Why are recloser and sectionalizer so popular? One of the main reasons is that they help to reduce a customer outage time. Most faults in the distribution system are temporary or transient. So instead of sending a maintenance or operation team to manually restore the power, recloser can clear the fault and restore service automatically within seconds. Also, by dividing the network into smaller sections, fewer customers are affected when a permanent fault happens. Another key advantage is the cost. Reclosers are much more economical compared to installing a full substation or additional circuit breakers. They are usually mounted on existing power pools, which means lower installation and site preparation costs. In addition, modern system supports more advanced protection schemes and smart grids application. And in the network with ring configuration, they enable features like automatic restoration and self-healing. So overall, they improve reliability, reduce costs, and support more advanced grid operation. So let us take a look at a typical application example using a simple scheme. Here, B represents the incomer, R represents the recloser, and S representing the sectionalizer. In this case, we have a radial distribution feeder coming from a substation. Along the line, we firstly have a feeder relay at the substation, then a recloser installed further down the line, followed by a sectionalizer with the different groups of the loads, load 1, 2, and 3. If fault happens near the end of the line, all protection devices will detect the fault and picked up typically through overcurrent. However, we always want the device closest to the fault to isolate it. Since the sectionalizer cannot interrupt the fault current, the upstream recloser will trip first. The sectionalizer detects that a fault occurred and starts counting the number of interruptions. After the first trip, the recloser will attempt to close again in case the fault was temporary. If the fault is still there, the recloser trips again and the sectionalizer counts another operation. Once the count reaches its set value, for example 2 operation in our example, the sectionalizer will open. This happens during the open or dead time of the last second shot of the recloser. After that, when the recloser closes again, the faulted section is already isolated and the rest of the line remains energized. So in this case, only a small part of the network is affected and most customers continue to have power. This is the main goal, to improve reliability and minimize the impact of faults. Now let us compare between the control testing and the relay testing. Now, let us compare between control testing and relay testing. In substation, protection relay are installed in a controlled environment conditions are stable and you are usually have enough time and space to set up your test equipment and connections. You can connect through test switches or terminal blocks and perform testing in a structured way. But with Recloser controllers, it's different. They are installed outdoors where the environmental conditions can vary, like heat, dust, or humidity, and this can affect the equipment over time. Also, testing in the field is more time sensitive. You often need to complete the setup and testing quickly. That's why fast and simple connections are very important. Using smart adapters with the ARCO 400 allow you to connect the controller very quickly in less than a minute and start testing without delay. So overall, Recloser testing requires a faster, more practical approach compared to traditional relay testing. Now let us look at the controller testing approach. The key idea here is that all signals we need for testing are available through the controller cable interface. This includes current and voltage measurement, as well as trip and close commands and the circuit breaker status signals. So instead of testing multiple parts separately, we can access everything from one point, the controller interface. During testing, we connect the ARCO 400 directly to the interface using smart adapters. This makes the setup very fast and simple. In most cases, it takes less than a minute to get ready. Another practical advantage is flexibility in the field. The ARCO 400 can even be powered using an inverter connected to a car battery, converting 12-volt DC to 220-volt AC. This makes it very useful for remote location where no direct power source is available. Now let's take a closer look at the ARCO 400 from the front view. This device is designed for field work, so portability is a key feature. It's lightweight, compact, and easy to carry, which makes it practical for testing and remote locations. All the main connections and indicators are located on the front panel. At the top, we have the control interface. You can connect a PC using a USB or Ethernet depending on your preferences. This is also an option to use a Wi-Fi adapter, which allows a wireless control, which is very useful when you want to operate the device from a distance. On the front panel, you also have LED indicators that show the breaker status for each phase, whether it's open or closed. This gives you a quick visual confirmation during testing. There is also a control button that allows you to simulate breaker operations directly from the device as open and close commands. For safety, the connectors are designed as touch-proof, meaning the pins are placed inside the connector so you don't accidentally touch them. Now, in terms of the outputs, the ARCO 400 can inject 3-phase currents and up to 6 voltage signals. For current, it provides up to 12.5 amp per phase, which is suitable for Recloser application due to the typical CT ratios used. For voltage, there are two ranges. A low range for higher accuracy with low-level signals coming out from the low-power voltage transformer up to 10 volt, and a higher range up to 150 volt for conventional voltage inputs. This allows flexibility depends on the type of the sensors used in the Recloser. In addition, the device supports up to 6 binary inputs and 9 outputs. These are used to read trip and close signals from the controller and to simulate breaker status signals like open command, close command, and lockout. Overall, the front panel is designed to give you everything you need: clear visibility, safe connections, and full control during testing. Now, let us talk about how the ARCO 400 is optimized for outdoor usage. Unlike traditional test equipment, which is mainly designed for indoor environments, this device is built specifically for field conditions. It has a rugged enclosure that protects it from choke scratches and rough handling during transport and use. Inside, the unit is designed to handle vibrations, so even if it's moved or shaken during the field conditions, it continues to operate reliably. Another important feature is the dust protection. The device includes a removable dust filter that helps prevent dirt from entering the unit. These filters can be easily cleaned and reused, which is very practical for dusty environments. In terms of temperature, the ARCO 400 is designed to operate within a defined range from -10 degrees Celsius up to +50 degrees Celsius. If the temperature goes beyond safe limits, either too hot or too cold, the device will automatically give warnings or shut down to protect itself. So it's built to handle real field conditions, heat, dust, and rough handling while still maintaining reliable performance. One of the key advantages of the ARCO 400 is the wide range of controller adapters available. These adapters are designed to support different types of Recloser and Sectionalizer controls, so you can easily connect to various manufacturers without complex setup. All of these adapters use Omicron Smart Connect technology, which is a plug-and-play technology. This means the device can automatically detect the connected adapter, including the pin configuration and the pin number. So there is no need for manual wiring or setup. This reduces error and saves time in the field. Another useful feature is the built-in breaker simulator. With this, you can perform a quick trip and close checks directly from the controller even without using the software. So you can verify basic functionality instantly. just using the open and close buttons. Now let's talk about smart controller adapters. To connect the ARCO400 to a different Recloser controllers, we use dedicated adapters. These adapters act as the interface between the test set and the controller, allowing quick and correct connections without manual wiring. Each adapter is designed for a specific control type or controller, for example, different pin configuration like 24-pin connections. The adapters themselves are short cables and they are typically used together with as extension cables up to 7 meters. The extension cables allows you to work comfortably in the field. For example, if the recloser is mounted high on the pole, you can connect the adapter at the top and perform testing from the ground. This makes the process much safer and more efficient. There are many types of adapters available to support different manufacturers and models. And if a specific adapter is not available, you can use a breakout box solution which allows a flexible and custom connections for any setup. And if a specific adapter is not available, you can use a breakout box solution which allows a flexible and custom connections for any setup. There are also additional accessories for voltage connections depending on how the signals are provided by the recloser. So overall, these smart adapters make the connection process fast, flexible, and suitable for a wide range of applications. So with Omicron Smart Connect technology, the setup is truly plug and play. The system automatically recognizes the connected adapter, so there is no need for manual configuration. Safety is also a key feature. All connections, including the test set extension cable and the adapters, are designed to be touch safe with no exposed pins. In addition, the software continuously monitors the setup. It can detect issues like missing ground connections and will warn you if live currents or voltage are active. From a usability point of view, the software makes it easy to start testing quickly. You simply select the controller relay type and begins your test. No complicated setup required. You also have different extension cable options, allowing you to work comfortably whether the controller is closed or mounted at a height. So in summary, there is a wide range of adapters available to cover different applications. For the full list, you can always check the Omicron website or reach out to us. Here are different types of smart adapters available for various controllers of the recloser manufacturers such as Eaton, Entech, Jinquang, SEL, and Siemens. To identify the adapter that best matches the pin-out configuration of your recloser, you simply need to check two things: the recloser switch type and the controller relay type. Once you know these details, you can proceed with ordering the correct adapter from us using the corresponding item numbers. However, to ensure you select the right adapters, you are welcome to share this information with us and we will be happy to assist. Now, let us look at some additional adapter options. In some cases, you may need a voltage adapter. This is used when a voltage signals or VTs are connected separately to the controller and not through the main control cable. It allows you to properly inject the measured voltage signals during testing. Another option is the BOB2, the Breakout Box, which is a general breakout box adapter. This is useful when you need more flexibility and if the combination of the recloser switch type and the controller type is not in our smart adapter list. So instead of using a dedicated controller adapter, you can connect signals manually using standard 4mm square test leads. It also provides additional binary inputs and outputs, which can be helpful in more complex testing scenarios. So this option gives you extra flexibility when standard adapters are not enough or when custom connections are required. So let us take a closer look at the Breakout Box BOB2. The BOB2 is a universal test adapter designed to work with ARCO400. It gives you full access to all inputs and outputs of the test set, which makes it very useful for flexible and custom testings. You have access for voltage outputs, current outputs, binary inputs, and binary outputs, as well as the auxiliary DC supply. There is also additional grounding connection for safety. This allows you to simulate all the required signals, including measurements, breaker status, and controller commands, without relying on a dedicated controller adapter. The connection to the ARCO400 is a plug-and-play, so setup is still quick and simple. Another important feature is the Breakout Box 2 configurator tool, and this tool allows you to create a custom configuration for different controllers and then integrate them directly into the ARCO control and ReCoPlan software. So if you are working with a controller that doesn't have a standard adapter, you can still build your own setup and use it seamlessly within the testing software. Overall, the Breakout Box provides maximum flexibility for advanced or non-standard testing scenarios. Here, another accessory called ISIO 200. The ISIO 200 is a binary input and output device with IEC 61850 communication support. The ISIO 200 is a binary input and output device with IEC 61850 communication support. It allows you to add up to 8 additional binary inputs to your testing setup. These inputs can be used for different purposes, such as pickup detection or general signal monitoring during tests. The device communicates using Goose message and IEC 61850 communication protocols, which make it suitable for modern digital substation and advanced applications. It's compact and easy to use, so it can be quickly integrated into your testing setup. In terms of power, it can be supplied either through a power over Ethernet or from an external DC source. It also includes an alarm output to indicate issues like communication loss or boost timeouts. So overall, the ISIO 200 adds more flexibility and expands your testing capabilities, especially when working with digital communication systems. Next, we will go through the ARCO control test workflow. ARCO control is the software used with the ARCO 400, and it's specifically designed for testing Recloser and Sectionalizer controller. It's a free software that you can download from the Omicron customer portal and install on a Windows PC. The main goal of this software is to make testing simple and fast, especially for field application. It provides a step-by-step guidance through the testing process, so you don't need to remember every detail. The software leads you through each test. Once the test is completed, the results are generated quickly and can be exported into HTML or PDF report. Now let us highlight a few key features. The input-output key is used to activate the outputs of the ARCO 400 and apply the test values. You also have a slider controller which allows you to adjust values easily without using the keyboard. In the hardware configuration, you define the settings of the controller under test as well as the ARCO 400 configuration. The system setting includes two types of settings. Firstly, application setting, for example, the curve management and the report options. And secondly, general software settings like language and sound. You can also see the test set information which shows the connected device and the current mode here at the bottom of the screen. There are also helpful shortcuts like access to video tutorials or the last test report, the user manual, and general software information. Next, we will go through the ARCO control modules. Software includes 8 dedicated tools that makes Recloser testing quick and straightforward. It automatically detects the connected hardware using a smart adapters, so there is a minimal setup required. It also supports post-protection testing and SCADA-related testings, and it works well with both touch screens or a standard keyboard and mouse. In addition, reporting is built in, so results can easily be saved and documented. Now, let us briefly go through the main test modules. The analog output check is used for basic wiring verification by injecting current and voltage signals. The backup tool is used to check protection thresholds, for example, when an overcurrent function starts to operate. The direct tool allows you to manually control outputs like current, voltage, phase angle, frequency, which is useful for troubleshooting. The sequencer tool allows you to create a custom test sequence up to 20 states for more advanced testing scenarios. The tripping sequence tool simulates full operation sequence like successful recloser or lookout sequence, including trip, reclose, and lookout to check the overall behavior. The trip time characteristic tool is used to verify protection curves and timing, including fast and slow curve behavior. The restoration tool is used for testing voltage-based function, especially in automation schemes. And finally, the harmonics tool is used to test when the controller responds to harmonic content such as the second or fifth harmonic, especially if the load have a distribution low voltage transformer, which might lead to the inrush phenomenon. So overall, this module gives you everything you need to perform both basic and advanced testing in a structured and efficient way. The ARCO 400 offers multiple ways to control the device depending on your preference and the testing situation. You can connect using Ethernet, which is commonly used for stable communication with a PC. There is also a USB option, which is simple for quick and direct connection. And for more flexibility, you can use Wi-Fi. With the Wi-Fi USB adapter, which called the EDMAX, you can control the device wirelessly from a PC or even an Android devices like phones or tablets. This is especially useful in the field where you may want to operate the test set from a distance, for example, from inside a vehicle or a safer location. Now let's look at how to standardize testing procedures using ReCoPlan. ReCoPlan is a PC-based software used to create and manage test plans for Recloser and Sectionalizer testing. You can either create a new test plan or open an existing one. When creating a new plan, you select the manufacturer, choose the controller adapters, and then add the required test tools. After that, you simply enter the test values. If you are using an existing plan, you can easily adapt it by adapting the controller setting using linked values. One of the main advantages of the ReCoPlan is that it provides a guided workflow. You can define complete testing procedures step by step, ensuring flexibility and consistency across different users and projects. There is also an instruction feature which allows you to add notes or guidance for the tester, for example, if manual action is required during the test. Once the test plan is ready, it can be executed directly in the ARCO control. At the end, you get a single combined report with all the test results in HTML or PDF formats. So in simple terms, ReCoPlan helps you to create, standardize, and reuse test plans, making testing faster and more consistent. Next, we will look at distribution automation scheme testing. With the growth of smart grids, distribution systems are becoming more complex. Reclosers are no longer working as standalone devices. They are part of a large automation scheme where multiple devices communicate and coordinate with each other. Because of this, testing only a single controller is not enough anymore. We also need to test how these devices interact, including the communication and overall system behavior. This is where synchronized testing becomes important. By using multiple ARCO 400 units synchronized with a GPS device, we can inject signals at the same time into a different controllers. This allows us to simulate a real system conditions and verify both protection performance and communication. RelaySimTest software is used for this type of testing. It allows you to model the system using a single line diagram and simulate a realistic fault condition. The software then calculates the required signals and applies them to the connected devices. With this approach, you can test the entire protection schemes, not just individual devices, including switching logic and communication between controllers. It also allows control of multiple test sets from a single PC, making the process efficient and coordinated. So overall, this method provides a more complete and realistic way to test modern distribution automation systems. Next, we will look at a DER protection testing. With the increasing integration of distributed energy resources like solar and wind, protection requirements are becoming more advanced. Grid codes now require proper validation of this protection function to ensure safe and stable operation. The ARCO 400 supports testing of the DER-related protection functions. This includes loss of mains protection, which detects when the grid is disconnected. It also includes rate of change of frequency, or RoCoF, which is used to detect rapid frequency changes. Another function is a vector shift protection, which identifies sudden change in phase angle. An important advantage is that you can test this function selectively. This means you don't need to disable other protection functions during testing, which makes the process faster and more efficient. Finally, let's summarize the key benefits of the ARCO 400. With proper testing, it improves the reliability of Recloser controls and ensures correct operation in the field. The plug-and-play approach makes testing quick and easy without the need of complex wiring or setup. It also supports the DER protection testing, helping you to meet the modern grid code requirements. The device is rugged and designed for outdoor use, so it performs well even in harsh conditions. At the same time, it's compact and lightweight, making it easy to carry and use it on site. With GPS synchronization, it also enables advanced testing of distribution automation schemes. And with user-friendly software and predefined test plans, testing becomes simple and efficient with no special training required. That brings us to the end of the overview. Thank you for watching, and we hope this gave you a clear understanding of how the ARCO 400 can simplify and improve Recloser control testing.